Okay, guys, today we're going to continue what we started last time. Last time we started in section 3 of chapter 18 about mapping the stars, and we said actually science they start to make a kind of map for the sky, like they're making a map for different countries on the earth. And we said they start to gather the different stars or different stars in certain arrangements or certain patterns. We call them constellations, and we said that regarding to these constellations, okay, they could use these stars in navigation and so on. And then they start to make a kind of map for this constellation. We said actually this map is not constant. Okay, the map changes because due to the Earth's rotation around its axis, the constellation somehow position changes. So regarding to and also due to the rotation of the Earth around the Sun, the constellation would be not in a fixed position. That's why we have different maps for different seasons, okay, and different maps for the north and the south poles of the Earth, because the constellations which cannot be seen from the north pole different than the constellation that could be seen from the south one. Okay, and that's how the map of the sky of northern pole look like. Okay, as you can see, the most important star here, Polaris, okay, at the top of the north pole exactly. Okay, and as you can see here, each constellation take a part of a sky that looks like a city in a country or something like this. Okay. Then here we said that how you could determine a location of a certain star. We said that we could use a tool. We called the astrolab. Okay, and we said that astrolab it's a tool that we could use to detect the position of a star or that determine the angle in which the star found at, okay, in the sky. And we said there are some definitions which are very important. Dennis said that the point which is directly above the observer, okay, to the sky, while altitude that represent the angle, okay, at which the star is found between Venice and the horizon. While the horizon, we said that it is the horizontal line where the sky met the earth, and we stopped at that point, guys. So today we're gonna keep talking here, okay, or just we are gonna find about more about the path or finding stars in the sky or something like this. We said that also here scientists, okay, so to determine how the location of stars related to the earth, because actually the astrolab just determine, okay, the star regarding to the point the observer stands on. But once we talk about what is the position of a star regarding to the entire earth, okay, we need another tool to use it. This tool we call the celestial sphere. Okay, so what is celestial sphere and what it is used for? Okay, that is the point which we need to know today. So I'm gonna show you a video, okay, and after the you watch this video, you're supposed to be able to answer the following question, okay. So here we ask what is number one, okay, two, three here. So after watching the video, I need to find what are the definition, what are these terms means, okay? So what is celestial square, declination, right? Says ascension, okay? So let's watch the video, guys. Pay attention and be careful. Get a paper or something to get your notes in, okay? Are you ready?
Yes.
Okay.
Here, I just wanted to talk to you about.
Okay, guys. Okay, after watching this video, now are you able to answer this question, guys? What do you think? So let's find here. What do you think, guys? So first, all we need here to ask what is the celestial, okay, equator. So who can answer me? Yes, Farah Mahlab.
It's an imaginary line when extending the Earth's equator to the sky, and it
Good.
divides the night sky into the northern part and the southern part.
Brilliant answer. Thank you for great work. Okay, so actually, celestial sphere, as you could observe, this celestial sphere, it seems to be like a huge sphere that surrounds the Earth. So if we just expand the Earth's equator to the sky, okay, they are going to create an imaginary line that we call celestial equator. As far as I said, it will divide the sky into two parts: northern sky and southern sky. Okay, so here we said that celestial sphere is an imaginary. First, there is no line in the space. Okay, line. Okay, created by expanding the Earth's equator to the sky. Okay, good. So like this, we know what is, that's number one. Okay. So what about declination? Who can tell me what are the declination, guys? Yes, Hanahani?
Yes, Mister.
Yep. What is declination? Yep.
It is a measurement to use to locate the stars on a map.
So measurement that represent what? Measurement in what? In
Latitude.
good degrees. Okay, the degrees like latitude. Good. Okay, so it seems to be like latitude on Earth. Okay, but instead of the word latitude, we say declination. So it represents how much degree north or south. Okay, celestial equator. So it could determine the position of a star or the position of whatever object in space in degrees above celestial equator or below celestial equator. Okay, north or south. Okay, by declination. So declination said that it is the measure in degrees. Okay, north or south the celestial equator. Very good, guys. Okay, so that's, for example, we can say like latitude. Okay, in that's look like latitude on Earth. So here, let's pass to the third one. Okay, what about the third one? Right ascension. Okay, so who can tell me what is right ascension? Is Ulta?
Are lines that extend from the vernal equinox that measure how east or west an object in the sky is, and every 15 degree is
1
uh,
hour.
is 1 hour.
Yeah, so that means right ascension is already measured in hours. Okay.
An hour.
Yes, so right ascension actually, guys, it represents a measurement in hours that represent how much the object is far, okay, eastward or southwestward, okay, especially eastward from the vernal equinox, okay. So here we have a very important question. What is vernal equinox? Okay, think in this point, okay, till I'm writing the answer. So we said that it is so who can tell me what is a vernal equinox, guys? Anyone have an answer? What that term means? Okay, anyone know? Yes, Hanahani, do you know? Hana Yasser, okay.
It's the center point of beside the right ascension.
Right, yep, it's considered to be the 0 point of, or the center point of the right ascension. Very good. But where is it, or what is it? How could we locate the vernal equinox? That means we could find it. Actually, we said that the vernal equinox is the location of the sun on the first day of spring. So where is the sun at the first day of spring? We call this vernal. Okay, so we said that location of sun in first day of spring. So here like this, regarding to this position, we're gonna find, okay, here like longitude, okay, longitudes, but instead of degrees, we're gonna use hours, okay. So we're gonna, regarding to this position to the vernal equinox, we could determine, okay, how much the object in space is far from the vernal equinox in hours. For example, 2 hours, that means 30° east, okay. 4 hours, that mean, okay, 6° east, and so on. Each hour represents 15°, okay, as longitudinal, okay, or as longitudinal lines on the earth. Is it clear here, guys?
Yes,
Guys,
yes.
yeah. So
Yes, yes.
let's try to apply this here, okay. We gonna see that. So that's here celestial sphere, and that's all the definition which we said. So as you could observe here, that's your Earth. So if we expand, okay, this equator outside, okay, to the space, that will create that celestial equator, which is going to divide the sky into 2 poles, okay, northern sky and southern sky. So regarding to the northern sky and southern sky here, we could able to describe the location or a position of a certain object in the star. For example, in the sky, like for example, this star. So to determine this location, we should know first how much up, or that is it above the celestial equator or below the celestial equator. So here we talk about the declination, how much degrees it's above or below. Then we need to know where is it regarding to the center of the earth, or we said that actually to the center of the sky, which is vernal equinox. That means how much far is it eastward, okay? So the vernal equinox, that is the vernal equinox. What is vernal equinox? That means at the first day of spring, actually, the sun will be here. So we're gonna determine how many hours, okay, eastward, okay, that is the star. For example, this star about 5 hours, which means it's about 75°, okay, away from this position, okay. Then, for example, 30° above, okay. So easily we determine the location of this star regarding to the Earth. So that's it, create a new part or a new definition here, which is ecliptic. Okay, so what is ecliptic? Ecliptic is the apparent path. Okay, that means it's a imaginary path of the sun across the sky throughout the year. That means we imagine in the first day of spring, the sun's supposed to be here. So if we are gonna move, okay, or we're gonna rotate as Earth rotates around, the sun. So the sun, it seems to be moving, okay. So that is the apparent path for the sun, okay. We call this ecliptic. Is it clear here, guys? Any hard question?
No.
No.
Yeah. So here like this, guys, that's how we could use celestial sphere, okay, to determine the position or the location of an object in the sky. So astrolab could be used to determine an object in the sky just regarding to the observer, okay, or the location of the observer. But here celestial sphere could be used to determine an object or to locate an object in the sky regarding to the Earth. So then, guys, here we are gonna pass to another part which is very important, okay. So we said that, sorry, we said here the path of the stars, or how these good point here to or we said that as the sun appears to move across the sky during the day, most stars and planets, okay, they have some kind of rise and set through the night. This apparent motion is called the Earth's, due to the Earth's rotation, okay, but actually it's not a true movement, okay, of that mean. Once the sun, okay, rotates around itself every day, we see that the sun rise from the east and just set in the west. But actually, is it a real movement of the sun, guys? Guys,
No.
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 So
There's
here,
no.
actually, we call this apparent movement due to the Earth's rotation around its axis. Okay, so stars and planets appear to move, or this apparent movement. So here, that's for a certain time or for a certain age, okay, we believe that the stars and they are moving, disappearing, or that is actually a movement of the stars. But later we find that it's just apparent movement due to the Earth's rotation around its axis. So that's lead to a very important question: is a star, or does a star, okay, move or not? That means stars already moving, planets already moving, or they don't move, okay? So actually we find later that stars, planets, of course, they could move, okay? So we find that, for example, the circumpolar star, okay, so that could be seen, okay, moved, or it can be seen, okay, within the year in different position, which means already this star is moving, okay? So that's laid a very important question, okay? Why we didn't observe the movement of the stars, okay? Or it's not easy to observe the movement of the star and something like this. So we said that in 1600s, okay? Copernicus, do you remember the Copernicus, guys? Do you
Yes,
remember Nicholas Copernicus?
uh,
Who's Copernicus?
helio
What is the theory of Copernicus?
heliocentric.
Yes, the heliocentric model, okay, which the first one, he said that the sun is the center of the universe and planets rotates around it, okay? So Copernicus, he, as one of his observation, and he studied that, he observed that the planets appear to move relative to the Earth, while stars did not. That means he observed that we could easily observe the movement of the planets from the Earth, okay? But we didn't observe that the stars move. So he started to think, because that the stars are more farther, okay, than the planets, because they are very far away from each other, so their movement is harder to be observed. So that means he believed that the stars already move, but we cannot observe its movement because they are very far apart from each other, okay? That's the same what happened, and you know, once you look from a window for a car, moving cars on a street, okay? So you could observe the closer movement, okay, or the closer cars, okay, that's under your window. You could easily observe their movement. But the more height you get, that means if you are living in a very high point on your building, okay, and there is a far car, for you will find its movement somehow not observed, or very, okay, slightly movement. Good idea, guys? Guys, do you imagine this?
Yes.
Yep, okay. So that's the same which Copernicus expected, because stars are located very far from our planet Earth, so we cannot observe its movement. So that's lead to, okay, or that's lead to try to find what are the distances, or how we could measure the distances between objects in the space, okay? So of course we know that, as you said before in science in lower grades, that the distance is measured in meter, miles, kilometers, and so on. But do you think these measurements or these units could fit the distances in the space, guys?
No.
No.
No, of course, because actually the size of the celestial spheres, or celestial objects like stars and some planets, and the distance between them are huge, okay? They could expand millions of kilometers, okay? So it's hard to use kilometer as a measuring unit. We need something, okay, bigger. That's which leads science to get a new measuring unit, which is known as light year. It's called light year. It seems to be a measurement of time, but actually here it's a measurement of distance, okay? That means light year is used to measure the distance between celestial objects, or between objects in space. So why we use a year here? Because actually we are gonna detect the distance regarding to the speed of light. So what is light year? We said that light year, it is the distance which is covered by light in 1 year. So if you know that the speed of the light is 300,000 kilometer per second, okay, that means each second the light could cover about 300, okay, 1,000 kilometers, okay. So here, imagine how much kilometer it could cover in a year. Do you imagine? Of course, it could be a huge number, okay? You get this, guys? So actually, 1 light year is about 9.46 trillion kilometer, okay? 9.46 trillion kilometer, okay? So that's a massive, okay, number, okay, that represent a huge, okay, distance that could found between objects. So imagine that we could say, for example, the distance between us and Polaris, or the distance between us or to that Jupiter, or something like this. is about 1 light year, 2 light years, and so on. So we talk about trillions and trillions of kilometers. You get this, guys?
Yes.
Okay. So like
Master.
that. Yep. Yes, right, Yusuf. You
I
come.
was
You
okay.
entered late. Okay.
No, I didn't enter because my laptop was turned off.
Okay, no problem. So here, like this, guys, the point which we are talking about here, okay, that this measuring, okay, or as you can see here, that represent that the size of the universe is too huge, okay, or if we get use of this kind of measuring unit, the light year, to express the distance between object and space, that will make you just to find out that the size of the or your scale, okay, or that's you're just like a point, okay, or just a drop on a sea. Imagine these guys are on an ocean, okay, because our planet Earth that carry all these forms of life, its diameter just measured in kilometers, okay, which means, okay, this kilometers is represent a very small decimal regarding to just 1 light year. So imagine that there are objects that expand far from you with 100, okay, light years. So how much the universe, how much big the universe is? It's very, very, very huge. Do you imagine this, guys? Okay.
Yes, Mr.
Okay. So here, like this, okay, we could find the idea, or we just regarding to this point, okay, we know how much the size the universe is, or something like that. Next time, inshallah, we're going to explain how science try to detect the size of the universe, how they start to locate objects that are very far from each other, okay, with this all these huge light years, okay, because of course regarding to this large distance, of course telescopes will not be enough or sufficient to detect all the information, and also we cannot of course pass this distance, okay, to observe this object and so on. So next time we're gonna know how science, okay, are studying the expanding of the space and so on. So any hard question regarding today's lesson, guys?
No,
Guys,
thank you.
anything's not
No,
clear?
thank you. No, thank you.
Okay, guys, please study this part very well from your textbook. We still have a little part in our lesson, then we're gonna finish it. Okay, once we finish, you're supposed to answer the section review. Okay, so please, okay, study this lesson well before going to the vacation, okay, because I know that you're gonna forget something and so on. So please study before, okay, you forget the info. So any question before I end our meeting, guys?
No, thanks.
No,
No,
thank
thank
you.
Thank you,
No,
guys.
thank you.
Goodbye.